Assalamu alaikum class. Today we are going to explain some example problems of chapter number 2. Here is the given circuit. It is an example of chapter number 2, 2.12. Here we have two diodes which is of silicon whose values are 0.7 of both. Here is the battery of 10 volt and the resistor of 0.03 kilo ohm. So we have to find V0 here, I1 current across this resistor, ID1 and ID2, the current across both diodes. So V0 can be found easily because these two diodes are in parallel. So the voltage across parallel elements is always same. So the voltage of these diodes are 0.7. So V0 becomes 0.7. Here we can see V0 is 0.7. Now we find the current across this resistor. Here we apply Ohm's law to find the current, which is I is equal to V divided by R. Here VR is the voltage across this resistor, which is E minus VD, and VD is the voltage of the diode. So the equation becomes total voltage minus voltage of diode divided by resistance. So I1 becomes 2.18 milliamperes. Now we have to find the current across both diodes. The total current is 2.8 and here the current is dividing in both sides. So in series the current divides. In series circuit the current divides. So current is dividing. We divide the total current, which is 2.818 milliampere, by 2, as there are two diodes. So the D1 and D2 become 14.09 milliamperes, which is our ID. So here we can find the answer. So here we have another example, which is 2.26. It is the given circuit. Now there is a Zener diode here. We have to find the Zener diode network, VL, VR, IZ and PZ. We have to find the voltage across here, this resistor, voltage across this resistor, Zener current here, and power. So for Zener diode, first we have to remove the Zener diode. We remove the Zener diode and the circuit becomes this. Now we have to find the voltage here, to find the voltage of VL. We can find the voltage here by voltage divider. So here is the equation of the voltage divider, RL VI divided by R plus RL, as we have to find the voltage here. So RL is in upside. So the equation becomes this, and our voltage is 0.873 volts. As 0.873 volt is less than V Zener voltage, so the Zener diode is off. So the voltage of VL, as these voltages are in same, so VL becomes 0.37. Now we have to find the voltage across this resistor. For voltage across this resistor, we can find easily by VI minus VL, which is 16 minus 8.73 volts, which becomes 7.27 volts. As we know that the voltage 8.37 is less than Zener voltage, which is 10 volt, so the Zener is off. Now for Zener current, the current will be 0 as the Zener is off. So the last thing is the power. We have to calculate the power. So the power here will also be 0, as the power formula is Vz Iz. As Iz is 0, so the power will be 0. Now the B part is we have to calculate the same process, but here RL will be 3 kilo ohms. Similarly, we apply voltage divider here, so the voltage become 12 volt. We remove the Zener diode and find the voltage. We find 12 volt. Now the 12 volt is greater than Zener voltage, so now the Zener is on. So the voltage across this resistor is 10, as the Zener is on and the voltage of Zener is 10. So the VL is 10. We can find VR by I minus VL. Similar formula, 16 minus 10, which becomes 6 volts. For Zener current, we have to find the current here, IR, and the current here, IL. The current IR and IR can be found by Ohm's law. We apply Ohm's law here for IL, VL divided by RL, 10 divided by 3, which becomes 3.33 milliampere. And for IR, VR divided by R is equal to 6 volt divided by 1 kilo ohms, which becomes 6 volt. Now we can easily find the Zener current, which is IR minus IL. So 6 minus 3.3 become 2.6 milliampere. So the Zener current is 2.6 milliampere. We can now easily find the power, as power formula is Vz Iz. So putting the value of the Zener current and Zener voltage, we can find power. The power is 2.6 milliwatt.